Hello and welcome to my science tutorials. In today's video, we want to look at some of the Cambridge AS and A-level coordinate geometry likely examination questions. Before we begin, if you're new to my science tutorial, make sure you subscribe to the channel and turn on the notification button so that you do not miss any of our latest tutorials. So without further ado, let's begin. So let's start by looking at some examples. Example number 1. We are to find the vertices of a triangle ABC whose sides are given by the lines AB, x minus 2y is equal to -1, BC, 7x plus 6y is equal to 53, and AC, 9x plus 2y is equal to 11. We are to show that the triangle is isosceles. Right, so let's go ahead and write down the solution for this problem. Now, from the diagram we have over here, this diagram shows the three lines that came together to form the triangle over here. Now, the vertices over here on point A, B, and C, in order for us to find these vertices, we need to solve two equations, or the equations of two lines that came to cross each other to form that particular vertex over there. So, for instance, if we want to find vertex A, we need to solve the equation x minus 2y is equal to -1 and 9x plus 2y is equal to 11, as these are the two lines that came together to meet at this point to give us vertex A. So let's go ahead and look at that. So for vertex A or point A, we need to solve the equation x minus 2y is equal to -1. This is our equation 1, and 9x plus 2y is equal to 11 as our equation 2. Now, if you compare equation 1 and equation 2, we have -2y over here, we have +2y over here. So I'm going to use the elimination method to solve these equations simultaneously. So I'll say add equation 1 and equation 2. So if I do that, I'm going to have x minus 2y is equal to -1 plus 9x plus 2y is equal to 11. So x plus 9x will give me 10x. -2y plus 2y will give me 0. This is equal to -1 plus 11 will give me 10. Now I have 10s is equal to 10. If I divide both sides by 10, s will give me a value of 1. Now that I have my value of x, I'll need to substitute x, which is equal to 1, into any of the equations, either equation 1 or equation 2. So I'll put it into equation 1 for this example. So I have 1 minus 2y is equal to -1. So I maintain my -2y here. That will be equal to -1 here. The +1 over here on the left hand side, I send it to the right hand side, it becomes -1. So I have -2y is equal to -2. I divide both sides by -2 to let my y stand alone, and my y will now give me a value of 1. So it means for the vertex A over here, it has the point or the coordinates x and y, and that is equal to x is 1, y is also 1. So that is the point for the vertex A. Now for the vertex B, we need to solve the equation of the two lines that came to form the vertex B, that is x minus 2y is equal to -1 and 7x plus 6y is equal to 53. So let's go ahead and look at that. So point B, as I mentioned earlier, we will be using the equation x minus 2y is equal to -1. This will be our equation 1, and 7x plus 6y is equal to 53 as our equation 2. Now, if I look at equation 1 and equation 2, if I multiply equation 1 by 3, I can get 6y over here, which I can cancel using the elimination method. So I'm going to start by saying multiply equation 1 by 3, and if I do that, that will give me 3x minus 6y is equal to 3. This becomes our equation 3. So I can now say add equation 2 and 3. By adding them, I have equation 2 is 7x plus 6y is equal to 53, and then equation 3 is 3x minus 6y is equal to 3. Now 7x plus 3x, that will give me 10x. 6y minus 6y will give me 0, so that is gone. 53 plus 3, sorry, this is minus 1. This is supposed to be minus 1 over here. So this is minus 3 here. This is minus 3. So 53 minus 3 will give me 50. So I divide both sides by 10. Then my x will give me a value of 5. If I substitute the value of x into any of the equations, let's say equation 1. Into equation 1, I'm going to have x minus 2y is equal to negative 1, which is the equation we have over here. X minus 2y is equal to negative 1. And then my x value is now 5, so I have 5 minus 2y is equal to negative 1. Negative 2y is equal to negative 1. I send the 5 to the right hand side, it becomes negative 5. So negative 2y is equal to negative 6. To find my y, I divide both sides by negative 2. So I have negative 6 on negative 2. And that will give me the y value of 3. So it means the points or the coordinates for my point B is x is equal to 5 and b is equal to 3. So the b over here has the points 5 and 3. Now let's go ahead and find the point or the coordinate for the vertex C. So to find the coordinate for vertex C, we need to solve the equation 9x plus 2y is equal to 11 and 7x plus 6y is equal to 53. So let's go ahead and do that and find the coordinates over there. So for point C, we'll be solving the two equations. 9x plus 2y is equal to 11 as our equation 1, and 7x plus 6y is equal to 53, this as our equation 2. So I see that I have 2y here, 2y over here. I'll say multiply equation 1 by 3. If I do that, I am going to get 27x plus 6y is equal to 33. From here, I can now say subtract equation 2 from equation 3. So I'm going to have 27x, this is my equation 3. So 27x plus 6y is equal to 33 minus 7x plus 6y is equal to 53. So 27x minus 7x will give me 20x. 6y minus 6y will give me 0. 33 minus 53 will give me negative 20. So if I divide both sides by 20, my x value becomes negative 1. If I substitute x value into any of the equations, say equation 1, I'm going to get 9 to bracket negative 1 plus 2y is equal to 11. So this gives me negative 9 plus 2y is equal to 11. I have 2y here is equal to 11. The negative 9 to the other side becomes plus 9. So 2y is equal to 20, and therefore y will be equal to 10. So it means for point C, my coordinates are x is equal to negative 1 and then y is equal to 10. So I have over here negative 1 and 10. So that completes the first aspect of this question, which demands that we find the coordinate of these vertices over here. Now the II aspect says that we should show that the triangle is isosceles. Now for an isosceles triangle, it has two of its lengths being equal, or the distance of two lengths of an isosceles triangle is equal. What it means is that we need to find the distance between, for instance, let's say point AB. We need to find distance AB, find the distance BC over here, and then we should also find the distance AC, and compare. If two of the distances are the same, then it means that our triangle is indeed an isosceles triangle. So let's go ahead and look at that. So let me erase everything here. Okay, so let's begin. So we have our point A has the coordinates 1, 1, B has the coordinates 5, 3, and C has the coordinate -1 and 10. And we have to find the distance of AB, then we find the distance BC, and then we also find the distance AC, and compare and see if they are all the same. Now to find the distance between 2 points, say AB, the formula is the root of s squared minus x1 all squared plus y squared minus y1 all squared. Okay, so for AB, A become x1 y1, and then B becomes x2 y2. So this is equal to, our x2 here is 5 minus x1, which is 1 squared, plus our y2 is 3 minus y1, which is 1 all squared. So this will give me, if I compute everything here, I'm going to have 4 squared, which is 16, plus here will give me 2 squared is 4, and then everything here will give me root 20. Now let me find BC. So the formula is still the same, s squared minus x1 all squared plus y2 minus y1 all squared. Now for this particular case, because we are using B and C, our coordinates will change. So since B is the first point over here, this becomes x1 y1, here is x2 y2. So this will be equal to, my x2 is -1 minus my x1 is 5, I square that, plus my y2 is 10 minus my y1, which is 3 all squared. So if I compute everything here into the calculator, -1 minus 5 will give me -6, minus 6 squared will give me 36, plus 10 minus 3 will give me 7 squared will give me 49, and then 36 plus 49 will give me the root of 85. Now the last one is to find AC. So for AC, the formula is still the same, x2 minus x1 all squared plus y2 minus y1 all squared. Alright, so since we have A and C, A becomes x1 y1, then this becomes x2 y2. So this is equal to, my x2 is -1 minus my x1 is 1 all squared, plus my y2 is 10 minus my y1, which is 1 all squared. So this will give me the root of -2 squared will give me 4, plus 10 minus 1 will give me 9. 9 squared is 81. So I have the root of 4 plus 81 will give me root 85. Now if you look at it, you realize that the distance BC is equal to the distance AC. Because BC is equal to AC, it means that the triangle that we're given is indeed an isosceles triangle, since the distance between two of the points are the same. Alright, so let's have a look at another example. So example number 2. Two sides of a parallelogram are formed by parts of the lines 2x minus y is equal to -9 and x minus 2y is equal to -9. We are to show these two lines on a graph, and find the coordinate of the vertex where they intersect. Now, for us to be able to draw or show this on a graph, we need to do the following. So solution. The first thing we say is, for the equation 2x minus y is equal to -9, we say let x be 0. And if x is 0, we have -y is equal to -9, and therefore it means that our y is equal to 9. So we have the coordinates 0 and 9. So we now say let y be 0. If y is equal to 0, now we have 2x is equal to -9, and then x will be equal to -9 on 2. So the second coordinate will be -9 on 2 and 0. Then for the second equation, we have x minus 2y is equal to -9. We do the same thing. Let x be equal to 0. So we have -2y is equal to -9. And then that will give us y to be equal to -9 on 2 will give me 9 on 2. Now we say let y be equal to 0. If y is equal to 0, then we have x is equal to -9. So here our point will be -9, 0. And for the first case over here, we are going to have our x is 0, our y is 9 on 2. Alright, so using these points here, this point, and this point, we can now draw this on the graph. So if we draw this, we are going to have a graph looking like this. Where this will be 2x minus y is equal to -9, and then here will be x minus 2y equals -9. Okay, so this is for this line, and then this is for this line over here. Alright, so the next thing we have to do is to find the coordinates of the vertices where they intersect. So it means where they intersect over here. Let me use another color for that. The point where they intersect over here, if you draw this on the graph really well, you can easily trace the x and then the y coordinates to get your answer. But since this is just a rough sketch, we need to solve this equation simultaneously in order for us to get the coordinates. So let's go ahead and do that. So we have 2x minus y is equal to -9 as our equation 1, and then x minus 2y is equal to -9 as our equation 2. Alright, so we have -2 here. I will say multiply. In order to use elimination method, I will say multiply equation 1 by 2. If I do that, I'll have 4x minus 2y is equal to -18. This will become my equation 3. Then I can now say subtract equation 2 from 3. So it becomes 3 minus 2. Okay, so I have my equation 3 here. 4x minus 2y equals -18. Then minus x minus 2y is equal to -9. So 4x minus x will give me 3x, minus 2y minus -2y will give me -2y plus 2y, and that will give me 0. So they cancel each other since we are subtracting. Now -18 minus -9 will give me -18 plus 9, and that will give me -9 over here. So I divide both sides by 3. The value of x will become -3. So if I substitute s is equal to -3 into equation 1, I'm going to have 2 into bracket -3 minus y is equal to minus 9. This gives me minus 6 minus y is equal to minus 9. And then minus y is equal to minus 9. The negative 6 goes to the other side of the equal to sign, becomes plus 6. And then minus y will give me minus 3 over here. Divide both sides by negative 1. Then this will cancel this. I have y to be equal to 3 now. So it means that my coordinates, okay, for the point of intersection of those two lines given by these two equations over here becomes my x value is minus 3 and then my y value is 3. So if I go back over here, it means the point over here is minus 3 and positive 3. So it means the x value here is minus 3 and then the y value here is positive 3 over here. Alright, so thank you so much for watching. This is how we solve some of the problems on coordinate geometry, specifically when you have two lines intersecting to create a point and you are asked to find the coordinate of that particular point. All you have to do is to solve the equations of those two lines simultaneously, either by the substitution or the elimination method, to get the two values, the x and then the y value, as the point or the coordinate of that particular point. So thank you once again for watching, and I will see you in the next video. Bye bye.